Hello and welcome back to this video series regarding the Intermediate Math League of Eastern Massachusetts. Today we're going to be finishing up the geometry section for Meet 5. So let's get right into it. Alright, so the only thing that we're going to be talking about today is surface area. And that's because Geometry Meet 5 focuses a lot on three-dimensional objects. And if you watched it, in the last video we talked about volume, which is the area inside three-dimensional objects. The other thing you can talk about is surface area, which is the area on the outside of three-dimensional objects. So the surface area is the area of the surfaces of 3D objects. So for example, if I had a sphere, it would be the area of just the big face covering the entire outside of this sphere. And before I get into the specific surface area formulas, because a few of them can look a little bit complicated, but they're actually more simple than you'd think, I want to look at just our regular area formulas for two-dimensional shapes, so I can draw some parallels between those to make them a little bit easier to understand and a little bit easier to memorize. Because unfortunately, we will have to memorize all of these surface area formulas because in only some of it you can do intuitively. So here are our useful regular area formulas for two-dimensional shapes. So to find the area of a rectangle, its area equals the base times the height. Pretty simple. For the circle, its area equals pi r squared. And then for a triangle, and I just included this one in case it ever comes up, but we won't have to look at this one in the surface area formulas I'm about to show you. Its area equals 1/2 base height. So it's like a rectangle, except you multiply by 1/2. All right. So let's move on to the area or surface area formulas. And the first one is the most simple one. It's the area of a rectangular prism. So I'll do my best to draw a rectangular prism so we can have a little bit of a diagram when I'm showing you. So there's one face, and then I can draw some faces in the back, just like this. All right, so it's not perfect, but let's imagine this is our rectangular prism. Now, if we wanted to find the surface area, that means if we look at each of these individual sides or faces, we have to find the area of each of these faces. So this one and this one and this one, and then the three on the back that aren't showing, right? So what you'll notice about these faces is two main things. First, they're all rectangles. Every single face on this rectangular prism is a rectangle. That's why it's called a rectangular prism. Which means that in order to find the area of one of the sides, all we have to do is use our two-dimensional rectangle formula, which I have here. The second thing you'll notice is that there are two sides on opposite of this rectangular prism that have the same area, that are identical. So what that means is, say I labeled this face 1, this one face 2, and that one face 3. Well, face 1 has an identical face on the back, right? So this face on the back that I'm pointing to that you can't see, and I'll draw dotted lines to show it, that's going to have an identical area because it has the same dimensions. And I'll draw dotted lines through here too to show the entire thing. Now, face 2 has an identical face on the bottom with the same dimensions, right? Because this dimension and that dimension are the same. And face 3 has one on the back here with identical dimensions and it has an identical area. So that means that if we find the areas of face 1 and 2 and 3, so say we find the areas of face 1 and 2 and 3, right? If we take those and multiply that all by 2, then we're taking all the other sides into account because they each have a second face that has an identical area. All right. So that means that's where this 2 comes from actually in this area formula, by the way. So in order to find the area of these three faces, now we just use a rectangle formula. If this is the length, this is the width, and this is the height, then the area of face 1 and then the identical one in the back is area equals length times height because it's base times width for a rectangle. For face 2, well, its dimensions are the length and the width. So you do area equals length width. And then for face 3, well, its dimensions are the width and the height. And so we do a rectangle formula, area equals base height, and multiply the width and the height. And those are the areas of these three faces. So now say we add them together, we get, okay, so I'll add this area here, length width, plus this area here, which is width height, and then this area here, which is length, height, that's the area of these three faces. And then if I multiply them by 2 to count for the faces on the back, that's our total surface area of the rectangular prism. And if you're ever in doubt, just take the length, width, and height and just calculate the area of each individual face and just add them all together. But that's where this formula comes from. That's why you have the 2 times the area of the 3 faces here. All right, moving on to the next surface area formula. And these are going to get progressively more complicated. The last 2 I can't explain fully because it's too complicated to explain. But the next one is a cylinder, and I can't explain this one fully. So a cylinder's shape that looks like this. So you have a circular bottom, and on the sides, you just have sides going up, and then you also have a circular top, just like this. And I'll draw the dotted lines to show the circle here. All right, so there's your circular bottom, the middle part, and then your circular top, right? And I'm actually gonna draw a better cylinder because it makes for better demonstration. All right, there we go, that's a better cylinder. It's like a can. All right, so you'll notice about the faces of these cylinders is that we have 2 flat faces and 1 curved one here, which wraps around in like a circular fashion like that. But for the 2 flat faces, they're just circles, right? We have a circle on the top and a circle on the bottom, which means that in order to find the area of those 2 faces, all we need to do is use the circle formula. So if we have our radius, then it'll be pi r squared. And since there are 2 of them, we multiply that by 2. And that's the area of these 2 faces, the one on the top and the one on the bottom. And that's where the 2 pi r squared comes from in this formula. Now, as for the 2 pi r h, that's slightly different. That's in order to find the area of this circular, I'm going to say wall around the cylinder. And the reason that it's 2 pi r h is because if you think about it, this is a little bit complicated. This wall here, if you, say you took the cylinder apart, say you had a can, right? And you take the top of the can off and the bottom of the can. You're left with just this empty cylinder. If you cut a hole in it and roll it out, it turns into a rectangle, right? Because, you know, if you take this rectangle and you roll it together, you could form the circular wall of the cylinder. But when you roll it out flat, it's just a rectangle. Which means if we can find this base here and this height here, when we multiply them, that will be the area of this rectangle and the surface area of this circular wall. So the height of it is just the height, right? That's the height of the cylinder here. That doesn't change. But in order to find the base, well, that's going to be the diameter of this entire part here, the diameter of the circular base. That's going to be the same length as this. So the diameter of a circle, the formula is, the circumference. So to find the circumference of a circle, that's just pi times 2r, or 2 pi r. 2 times pi times the radius. So if this base length here is 2 times pi times the radius, and then the height is just the height of the cylinder, then all you need to do to find the area of this rectangle here, which is also the surface area of this circular wall, is multiply base times height to get 2 pi r h. And that's where this part comes from. And then now you've taken into account every single part of the cylinder. So if you add those 2 together, 2 pi r h and 2 pi r squared, that gets you your total surface area formula. All right, on to the next 2. And these 2, I'm not going to explain fully. I'll explain part of one of them, but you're just going to have to memorize these, unfortunately. All right, the surface area of a cone. This formula is a wreck. It's very, very untidy, and you just have to memorize all of it. But part of it that helps is you see this pi r squared here. What this comes from is if you have a cone, it has a circular base, right? And the rest is just this pointy cone part. And that's where this part comes in. And you can ignore that if you want and just straight up memorize this. But remember that this circle, this circular base is just the area of a circle. So if you have the radius of this, it's pi r squared. And that's where the pi r squared comes from. in this formula. And so if it's ever asking you, say, just to find the surface area of just this outside part of the cone, but not the bottom, and I don't know why it might ask you that, but say you had a question that asked you that, you would know to adjust the cone formula and just take this part out, because that's the area of the bottom face, because it's the circle. And then this would get you the surface area of the rest of the cone. All right, and finally, on to the last one, the sphere. So the surface area of a sphere is 4 pi r squared. I'm not going to try to explain this one, it's too complicated. But if you want to remember it, simply it's just 4 times the area of a circle. That's the formula, right? If the radius of the cone, or the radius of the sphere is like the radius of the circle, you do pi r squared and multiply it by 4. And oh yeah, one last note I forgot to touch upon. If you're wondering what this means square root. So in the cone formula, you have area equals pi times r times, and then I put this all in parentheses to try and make it clear, the square root of r squared plus h squared. So the radius squared plus the height squared. So you do this part first. You do radius squared plus height squared, and then you find the square root of all of that. And you can use your calculator for this, and then you multiply it by pi and the radius, and then if you need to, add it to the base of the cone. All right, so on the slide here, I have one surface area question, and it's what I consider a difficult surface area question for, say, IMLEM to ask. And the reason why isn't because the calculations at the end are difficult, but getting to that point is what is very difficult. Because you'll notice if you read the question, this is a very confusing question. There are a lot of numbers being thrown at you. There's a really specific scenario that might be a little bit difficult to understand being thrown at you. And so one of the skills, especially in geometry, that needs to be worked on is actually figuring out how to solve the question in the first place. Because there are 2 types of questions that IMLEM can ask that might be difficult. One of them is just difficult calculations. You have to plug a lot of numbers into your calculator, and that just comes with hard work. You need to check your answers, and you need to make sure you're doing all of those calculations right. But the second type is the more conceptual questions, where you need to be able to visualize what they're asking and set up the question. So that's actually something that is largely ignored but should be practiced. And that's what we're doing with this slide. I'm going to go over how to break down a difficult surface area question. So let's read the question. It says, a cylinder rests on top of a rectangular prism, with its flat base fully in contact with the top of the rectangular prism. The diameter of the base of the cylinder is 1/2 the length of the rectangular prism. The length of the rectangular prism is 2 centimeters less than the width. The width is 2 centimeters less than the height, and the height is equal to the height of the cylinder. If the height of the cylinder is 10 centimeters, what is the total surface area of the figure? All right, so when I get overwhelmed by a question, if a lot is being thrown at me, there are 2 main steps that I do. The first is I highlight what it's actually asking, right? So this is the part that it's actually asking. What is the total surface area of the figure? So it's talking about some type of figure in this question, and it wants us to find the total surface area. Great, now we know what we're looking for. Next, we need to identify what the figure is, because it's more important to figure out what the figure is it's talking about, or what the setup is, especially with volume or surface area questions, before you go about doing any of the calculations, because that's how you set up the calculations in the first place. So in the first sentence, it says a cylinder rests on top of a rectangular prism, with its flat base fully in contact with the top of the rectangular prism. All right, cool. The rest of the question doesn't give us any more information to what this figure actually looks like. So I think one good step when there's a lot of information being thrown at, so we can kind of consolidate our information into one place, is making a diagram, right? So I'll make a diagram of this. So we know we have a rectangular prism in this diagram because it says there's a cylinder on top of this rectangular prism. All right, so this is not going to be to scale with the question, but that doesn't really matter at this point, because right now we're just trying to visualize what it's asking in the first place. All right, so we have a rectangular prism, and it says a cylinder rests on top of it with its flat base, which means its circular base, fully in contact with the top. Okay, so if its circular base is fully in contact with the top, it's not somewhere like over here, because that's partially off. So it's going to be somewhere in the center. It doesn't really matter where. but let's just put it somewhere in the center, like this, and then we can draw a cylinder. And that was a very bad line. Let me use the straight line tool. There we go. And now we have our cylinder that's going to be on top of this rectangular prism. All right, cool. And I know you can see through the back of the cylinder with these lines here, but let's just pretend this is our diagram. All right, so now that we have our diagram, we can think about what it's asking and now figure out what we need, right? Because we have our diagram, there are a lot of numbers here, which we're assumably going to use to solve the question. But what it's asking is to find the total surface area of the figure. So what that means is we need to find the surface area of all of the sides of this rectangular prism and all of the sides of this cylinder, except not this side, right? Because this side is what's touching the rectangular prism. So that's not being accounted into the total surface area. So then what we would actually need to do if we're going to set up an equation is we do surface area, so SA, of this rectangular prism, which will do R, so surface area of the rectangular prism, plus the surface area of this cone, right? So plus the surface area of the cone, and then SAC, that's what we'll call it, except minus the surface area, or the area of this bottom base here. And we actually need to subtract that twice, 2 pi r squared. And the reason why is because first, it's when we find the surface area of the entire cylinder, it is being, this bottom base is being taken into account, right? And we shouldn't take it into account. So if we find the surface area of this entire cylinder, we need to make sure to take 1 pi r squared out because we're not taking into account the bottom base. But the reason why we need to subtract it a second time is because it's also taking away from the surface area of this rectangular prism, right? Because it's blocking part of the top base, and that part of the top base, that surface area, isn't going to be counted, which means that we actually need to subtract it a second time. And then that's going to get us the total surface area of this entire figure. So this is the equation that we need to look for. All right, now we get into the nitty-gritty stuff, the calculation part, where we need to just figure out the length of all the sides. Now, I'm going to go through this step, but I'm not actually going to evaluate the question. Right, we just need to find all of the variables that we need. So we need the radius, we need to find the length, the width, the height. Oops, I wrote the length as the height. So the length is that one. And then we also need the height of this cylinder here. So it says the diameter of the base of the cylinder is 1/2 the length of the rectangular prism. Great, so if we can find the length of the rectangular prism, we can find the diameter and then the radius of this cylinder. And then it says the length of the rectangular prism is 2 centimeters less than the width. So if we find the width, we find the length, then we find the radius. The width is 2 centimeters less than the height. So then if we find the height, we find the width, and so on. And then the height is equal to the height of the cylinder. Okay, so if we find the height of the cylinder, then we find this height, and so on. If the height of the cylinder is 10 centimeters, and then our question. All right, so here's the key piece of information. The height of the cylinder is 10 centimeters. So first we can write this height is equal to 10 centimeters. Okay, now we can do all of our information drawing from that. The height of the rectangular prism is equal to the height of the cylinder, so this is also 10 centimeters. The width is 2 less, so the width is going to be 8. The length is 2 less than that, so the length is going to be equal to 6 centimeters. And then the diameter of the base of the cylinder is 1/2 the length of the rectangular prism. So the diameter of this base, which is, remember, all the way across, is going to be 3 centimeters, which means the radius, which is half of that, is 1.5 centimeters. So 1.5 centimeters as our radius. All right, so now that we have all of our variables, we have all of those values, all we need to do is use our surface area equations, which you should remember as this one as 2 times length width plus width height plus length height, and then plus the surface area of a cylinder, which is 2 pi r squared for the 2 bases. And remember, we take that into account, that one of them shouldn't be counted, plus 2 pi rh for the circular wall, and then minus 2 pi r. And from here, all you have to do is substitute values in, and you'll get your final answer for the total surface area of this figure. All right, so now I have a review question. If you'd like to try it, I'll give you a few seconds to pause the video, and then I'll explain the answer. All right, so the correct answer to this question was 62.5 pi centimeters squared. All right, so let's read the question. It says a cube has a surface area of 150 centimeters squared. A cylinder that is twice the height of the cube has a base that could fit perfectly on top of the cube's top face. And there should be an apostrophe here, I just realized. What is the surface area of the cylinder in terms of pi? All right, so first step is just to figure out what it's asking and isolate that from the question. That's the last sentence. What is the surface area of the cylinder in terms of pi? And in terms of pi, just means that we're not going to use 3 or 3.1 or 3.14 as the value of pi. We're just going to keep it as pi in the question and keep it as pi in our answer. So it's asking us to find the surface area of the cylinder. Great. Now we need to imagine what it's talking about with the rest of the question. So it says a cube has a surface area of 150 centimeters. So let's draw a cube, right? So I'll do my best to draw a cube. So remember, a cube has all square faces, right? The side lengths of the cube are all the same. So I'll do my best to draw that. So there we go. That's our cube. Imagine all of these side lengths are the same. So a cube has a surface area of 150 centimeters. The surface area equals 150 centimeters squared. A cylinder that is twice the height of the cube has a base that could fit perfectly on top of the cube's top face. So now we also are talking about a cylinder in this question. And if it's twice the height, I'm going to do my best to roughly draw a cylinder that's twice the height of this cube, right? A cylinder that's twice the height. And I know this isn't a perfect cylinder, but I'm doing my best. And it says it has a base that could fit perfectly on top of the cube's top face. All right, now here's where it gets confusing. What this means is that if it could fit perfectly on top of the cube's face, notice it doesn't say that it could fit on top of the cube's face. It means it says it could fit perfectly on top. That means that the circular base would reach all of the edges of this cube, which means that this length all the way across is the same length of one of these edges of the cube, right? So the radius, if we can figure out what an edge length of the cube is, we can figure out this radius, because it's just going to be 1/2 the diameter of the circle, or 1/2 that edge length. All right, and now this is where we get into figuring out how to solve the question. We need to find the surface area of a cylinder. Let's write out our surface area formula first. So surface area of a cylinder is going to be equal to 2 pi r squared for your two circular bases, plus 2 pi r h. So that's just for the circular wall. So we know that the height is twice the height of the cube, and we know that we can find the radius if we can find the length of just one of the sides of the cube. Now, what people sometimes forget when it comes to cubes is that all of the lengths are the same, which means that the length is equal to the width, and the width is equal to the height. So which means every single face on this cube has the exact same area. So therefore, we can use that to figure out what one edge length of the cube is, because we need to know the edge length of this cube, in order to find all the rest of the things we need to calculate the surface area of the cylinder. Now, if the cube has a surface area of 150 centimeters, you could do the way where you're like, okay, area equals 2 times length width times, or plus width height, plus length height, right? And that's not wrong. These are all equal, and it might take you a while. One other thing that you could do is you could say, well, all of these areas of all of the faces are the same. So if we take 150 divided by 6, that gets us 25. So the area of just one face of this cube is 25 centimeters squared. And since every face of the cube is a square, that means the two side lengths here are the same, which means that each side length has to be 5. 5 here, 5 here, 5 everywhere else. Because when we do 5 times 5, one face has an area of 25 centimeters squared, so 6 of them have a total surface area of 150 centimeters squared. All right, so now that we have our edge length of the cube as 5 centimeters, now we can figure out what the values are to calculate the surface area of the cylinder, right? So it says the cylinder is twice the height of the cube. Well, the height of the cube is 5 because that's the side length. So the height of the cylinder then is 10 centimeters. So 10 centimeters equals h, or height of the cylinder. All right, now remember, if the base perfectly fits on top, then to go across the base, all the way across, which is the diameter, is going to be equal to the edge length of the cube. So the diameter of one of the bases all the way across is 5 centimeters, which means that the radius, which is half the length of the diameter, is going to be 2.5 centimeters, or 2.5. And you will have to deal with decimals, but it's not as scary as other meats because you can put it into your calculator. So 2.5 centimeters equals our radius. And now we don't need to figure out any other variables because remember, pi is a constant, there are no other variables, and we can express things in terms of pi. And this is where you do what we call plugging and chugging. You stick all the numbers into your formula and put it in your calculator and get your answer. So 2 times pi times 2.5 squared plus 2 times pi, I don't know why I put parentheses there. Let me undo that. 2 times pi times 2.5, because that's the radius, times 10, which is the height. And you could solve these separately and add them, but eventually you're just going to get surface area equals 12.5 pi plus 50 pi centimeters squared, and then that gets you to 62.5 pi centimeters squared as your final answer. All right, just to review what we've learned this lesson, we talked all about surface area, which is the area of the faces or the outside of a three-dimensional object. And in order to understand some of the surface area formulas, we first looked back over our regular 2D object area formulas, and then went over 4 different surface area formulas, which are right here. Pause if you need to memorize them or look at them again. All right, then we talked about how to break down surface area questions, which is more talking about the conceptual types of questions, where it's not difficult to do the calculations because you use a formula, but rather to come up with your equation in the first place and figure out what the question is asking. And the best way to do this is to highlight what the question is asking, and which is in this one, what is the total surface area of the figure? Then try to draw a diagram of what it's asking about. And then if you can, figure out what variables you need to find and how you can do that through the question one by one. And then finally, we went over a review question where we applied those strategies and figured out that the total surface area of the cylinder in terms of pi is 62.5 pi centimeters squared. All right, that's all I have for today's lesson. Thank you, and I hope that's helpful. See you next time.